Good morning, students. Hello, everyone. This is exercise of chapter 11, Dual Nature of Radiation and Matter. Questions are from 11.14 to 11.16. The first question is wavelength of light from spectral emission line of sodium is 589 nanometer. Wavelength is given. Find kinetic energy at which an electron and a neutron would have same de Broglie wavelength. Okay, there is same wavelength for electron and neutron, and we have to find their kinetic energy. Wavelength is given. So this is a solution. Wavelength is given. Wavelength lambda is equal to 589 nanometer. Nano means 10 raised to power minus 9. So we have to find kinetic energy. So this is the formula of kinetic energy in terms of momentum. K is equal to P square upon 2m. K is the kinetic energy, P is the linear momentum, and m is the mass. So we know that linear momentum P is equal to h upon lambda. Put the value of P in above equation. So K is equal to h square upon 2m lambda square. Put the values of h, m and lambda and then solve. H is 6.62 into 10 raised to power minus 34 का whole square upon 2 into mass of electron 9.1 into 10 raised to power minus 31 multiply lambda square. Put the value of lambda, then solve. We will get this answer. Kinetic energy is equal to 6.94 multiply 10 raised to power minus 25 joule. Then convert this into electron volt by dividing 1.6 into 10 raised to power minus 19. On solving, we will get 4.34 into 10 raised to power minus 6 electron volt, and we know that 10 raised to power minus 6 is equal to micro, so the result will be 4.34 micro electron volt. So this is the kinetic energy of electron. Now we have to find the kinetic energy of neutron. The same formula, K is equal to P square upon 2m. P is equal to h upon lambda. Put the value. So K is equal to h square upon 2m lambda square. Put the values, h same. To mass of neutron will be different here. 1.67 into 10 raised to power minus 27. Wavelength is same. Then solve. We will get finally 2.36 nano electron volt. This is the kinetic energy of neutron. This is the first question. Then question number 11.15. What is the de Broglie wavelength of a bullet of mass and speed is given, mass is given. Second, a ball of mass and speed are changed. And third one, again a dust particle of mass and speed again changed. There are three parts of this question. All three are similar. Mass is changed and speed is changed. Same formula will be used to find the de Broglie wavelength. So this is the first part. Here mass is equal to 0.040 kilogram. Speed is given 1 kilometer per second. Convert kilometer into meter. So speed will be 1000 meter per second. What we have to find, that is lambda wavelength. So formula is lambda is equal to h upon mv. Mass is given, speed is given, and h is a constant. Put all the values like this. H is 6.62 into 10 raised to power minus 34, and mass is 0.04 and speed is 1000 meter per second. On solving, we will get 1.7 into 10 raised to power minus 35 meter. Next, B part. In B part, mass is 0.06 kg and speed is 1 meter per second. Same formula we will use, h upon mv. Put the value of h 6.62 into 10 raised to power minus 34. Mass is 0.06 and speed is 1. On solving, we will get 1.1 into 10 raised to power minus 32 meter. This is part C, in which same formula lambda will be used, h upon mv. Mass is different here, 1 into 10 raised to power minus 9 kg and speed is 2.2 meter per second. Lambda we have to find, put all the values and solve. We will get lambda is equal to 3.0 into 10 raised to power minus 25 meter. So these three parts are over. Now next question, question number 16, 11.16. An electron and a photon each have a wavelength of 1 nanometer. Find their momenta, energy of photon and kinetic energy of electron. What is given in this question? Wavelength is given, lambda is equal to 1 nanometer, and then momentum of electron and momentum of photon we have to find, energy of photon we have to find, and kinetic energy of electron we have to find. So lambda is this, and momentum of photon and electron will be same as both have same wavelength. What is the formula of momentum? P is equal to h upon lambda. Here h is a constant. It means momentum depends upon wavelength. As wavelength of photon and electron are same, so momentum will be same. So that will be equal to momentum of photon, that is equal to momentum of electron in this condition, that is equal to 6.62 into 10 raised to power minus 34 divided by wavelength 10 raised to power minus 9. On solving, we will get 6.62 into 10 raised to power minus 25 kilogram meter per second. This is the momentum of photon and electron, both are same. This is the second part, energy of photon. The formula of energy is E is equal to h nu. Here nu frequency is not given, wavelength is given. So we will use formula E is equal to hc upon lambda. So h is constant, c is constant, lambda is given. Put the values, h is 6.62 into 10 raised to power minus 34, multiply c, speed of light, 3 into 10 raised to power 8 divided by lambda wavelength, that is 10 raised to power minus 9. On solving, we will get 19.89 into 10 raised to power minus 17 joule. We can convert it into electron volt as well by dividing 1.6 into 10 raised to power minus 19. So answer will be in electron volt. Next, C part, kinetic energy of electron. So what is the formula of kinetic energy in terms of momentum? K is equal to P square upon 2m. But here wavelength is given, but P we have already calculated in part 1. So P is equal to 6.62 into 10 raised to power minus 25 and 2m. M is the mass of electron. So we can solve. M is mass of electron, that is 9.1 into 10 raised to power minus 31 meter. Put both the values and solve. We will get K is equal to 2.41 into 10 raised to power minus 19 joule. That is equal to 1.51 electron volt. This is the third part of question number 16. Thank you. Have a nice day.